Today we are going to discuss some problems related to the particular integral of a linear differential equation with constant coefficients. So let us start with the case 1 related problems. So first one you can write, find the particular integral of 4d square plus 4d minus 3 of y is equal to e to the power 2x plus 5. Okay, so and here we are going to find out the particular integral. So we write here where what is the value of d. D is nothing but d by dx. Okay, so let us try to find out the particular integral of this differential equation given. So what I do, I'll write y is equal to particular integral is equal to, okay, as per the discussion of case 1, we can write it as f of d. What is that f of d here? 4d square plus 4d minus 3, and here it is e power 2x plus 5 is there, so we are going to break that. Okay, and we write 4d square plus 4d minus 3 5 here. Okay, we used to write it separately. Now case 1 says that when we have exponential term in RHS, while finding particular integral, we have to replace d by a, d square by a square, etc. Right? So what we do is, in the first problem, okay, in the first problem, we take a is equal to, what is that, 2. A is equal to 2, and here this constant 5 can be taken as 5 into e to the power of 0x. Okay, therefore this is 0, the value of a. Okay, so now we replace d by a, d square by a square, etc. So let us do that. So we get 1 by 4 into d square. What is d square? A square. What is a? 2. 2 square means 4. Okay, so 4 into 4, 16, plus 4 into 2, 8, minus 3. Okay, so write e power 2x as it is, plus here while replacing d by a, d square by a square, we look into the value of a. What is a here? 0. So wherever you have d, just you put 0. That becomes 1 by minus 3 into e to the power of 0x into 5. We write only 5. So that the answer becomes e to the power of 2x divided by, we can simplify this. Okay, so by simplification we are going to get e power 2x upon 21 minus 5 by 3. This becomes the pi, the particular integral of the given differential equation. Okay, good. So now let us go for some more problems here. So take this as the problem number 1. Let us go for the problem number 2. Is that okay? Yeah. So now we'll go for the next problem. So what is that next problem? It is here. We write find the particular integral of, find the particular integral of, what is that, d cube minus 3d square plus 4 of y is equal to e to the power of 2x, where d is equal to d by dx. Okay, so here also we proceed as in the first problem. So we write y is equal to pi is equal to 1 upon d cube minus 3d square plus 4 of e to the power of 2x. Okay, so that means we have to replace d by a, d square by a square, d cube by a cube, etc. What is the value of a here? It is 2. Okay, so when I replace d by a, d square by a square, d cube by a cube, we are going to get 0 in the denominator of f of d. Is that okay? So in order to overcome this, we have to multiply by the independent variable. Here independent variable is x, and differentiate the denominator with respect to d. What is that? We get 3d square, the derivative of d cube, minus 6 into d, that is 3 into 2d, we get 6d, derivative 4 is 0, we write e power 2x as it is. Okay, yeah. So now again we have to continue with the replacement of d by a, d square by a square, etc. So even here, while replacing d by a, d square by a square, we are going to get 0 in the denominator. You can see that 3 into 4, 12, minus 6 into 2, 12. 12 minus 12, 0. That is the case of failure again. So multiply one more time by x, that becomes x into x square, and differentiate one more time with respect to d, the denominator. So we get 3 into 2d, that becomes 6d minus 6 into e to the power of 2x. Okay, and one more time replace d square by a square, d by a, etc., so that we get here 1 upon 6 into 2, 12 minus 6, you get 6 into e to the power of 2x. Therefore we don't get 0 here, so that is giving us the complete material, x square into e to the power of 2x upon 6. This becomes the pi of the given differential equation. Okay.